Welcome everybody to Oricon office. Thank you so much for coming along tonight. It's great to see so many of you. So I just want to introduce myself. I'm Sarah Hodson and I'm the new chair of the newly inaugurated Spatial stream. And we're having this event in collaboration with Women in Spatial and Survey. So welcome along. This is great. I'm really excited to help launch this stream. I've actually been doing geospatial for 21 years now. And literally for the past 21 years, whenever I say to someone, I work in geospatial, they give me an expression like rigor mortis and want to get away from me. People don't understand what that means. And I think from all the different people that I talk to across our own sector and also outside of the sector, we don't really market ourselves too well either. I think we struggle to explain what it is that we do and the benefit that we can bring, because people have started talking recently saying, oh, geospatial, that's really exciting. It's new and it's going to be everything. It's like, it's actually not new. It's been around probably since the 70s. It's just people are getting that awareness of how it can help all of the different sectors and industries. So this spatial stream is one of those safe places where everybody who has an interest in spatial, who wants to know more about it, or who already does spatial can come along and get involved. It's sector agnostic. Everybody, as we just established, is using geospatial. There's lots of different ways it's used. When I was at Defence Force, I was doing mapping and geospatial for disaster response and humanitarian assistance. When I was at police, I was doing crime analysis and mapping and finding where bodies might have been buried on imagery, and that was really interesting. Now I'm at Oricon and it's digital engineering, and that's also quite fascinating, deep dive into a completely different sector again, but they've all covered geospatial. And so that's what I want everybody here to feel welcome to bring their stories of how they use it. It's also technology agnostic, because arguing over what software you use is about as silly as arguing whether you like an Android or an iPhone. At the end of the day, they both call, they both text, you can surf the internet, you can get the same apps, whether you're looking at the App Store or Google Drive. So let's just step back and go, how does everybody use the tools and how can we make more use of them from what other people are doing and bring it together? There's so many cool things to learn from each other, but there's also ways that we can share what we're doing with others better. And so I'm joined tonight by my newly inaugurated committee members as well, which I'm very excited to have with us. So we have Sam from Woods, and we have Gisela from Chiel, and we have Murdad also. So unfortunately tonight we couldn't have Anne Harper join us. She was unwell. So Murdad is going to give a really interesting presentation instead. And we're also going to hear from Kirsty shortly and Bruce from Global Survey. And then we also have Sam from Allsight. So really great speakers, really looking forward to everybody being involved. And thank you to Oricon for hosting this. Our President of Survey and Spatial, Andrew Perry, is joining us online. So welcome to you all online as well. Thank you for coming along and persevering with us. Everybody was having such a lovely time next door, mingling and chatting, that we had to go and do a bit of a shout to get them all involved. So here we are. I'm going to pass now to some of my committee members so that they can welcome you and share what they'd like to achieve from our committee.
I'll get myself out of the way, Kirsty. As Sarah mentioned, I'm Sam Smith, very original name, from Woods. And if anyone knows Woods, there's like 30 Sams at Woods, so it's not even original in my own company. I've been doing, I guess, spatial things for about 14 years, mainly in laser scanning, but we do UAV and, I say proper GIS, but desktop GIS, we do photogrammetry, all sorts of things. So what drove me to I guess put my hand up for this is that everyone is involved in spatial in some way already, and really just trying to drive that conversation and I guess let people realize that they are doing it, and that they can keep doing it and contribute in really simple ways just by doing what we do every day. So yeah, pretty excited to see what comes next.
Gisela, would you like to say a few words?
Hi, I'm Gisela. My name is a bit more
Original.
Yeah, I'm from Chile. I lead the special team there, based in Taupo. From Argentina originally, been in New Zealand and with the company for about 8 years. I'm a surveyor, mostly UAV and laser scanning. Got into GIS about like 4 years ago, so it's like reasonably new. And yeah, I just love learning and sharing my knowledge. So I think from the stream, we could create a space to have good conversations and yeah, that was the main motivation for me to learn that.
Hello, I am Merdas, and I'm I've been working in GIS industry since 2006. Yep, and I have bachelor in surveying, master's in GIS engineering, and PhD in air pollution modeling using geospatial techniques. And I'm working with Waste Management New Zealand. If you don't know Waste Management New Zealand, it is rubbish. And yeah, I hope we can get together and learn from each other. That's it. Thank you.
Thanks, Murdad. So one of the things that we're looking at doing as a committee is bringing ways that we can get recognition for all of the work that people do across the geospatial profession, because surveyors are well known, they're well established, and they have a really great pathway that they can follow. And they're also recognised by the government and leading industry bodies. That's not the same for geospatial people. Lots of people fall into geospatial in different ways, and that's fascinating. Love hearing everyone's backstories. But you also can't really compare what someone does to someone else. And I think it's really important that we establish those CPD points for attending events or doing learning or different projects that you've been involved with, so that there's some level of industry awareness beyond just our small network that is GIS in New Zealand, that we've achieved certain proficiencies or we've worked on certain projects, so that people can have that familiarity with what geospatial brings, but also the benefits of certain people in certain situations outside of just knowing each other and what we do. So we're going to talk to different software players and different experts in Survey and Spatial NZ itself. We have Stevie, who looks at all of those proficiencies and training opportunities and how we can improve CPD points. So that's something that we'll be focusing on, and also bringing everybody together like this more regularly. So we have some amazing industry events already across New Zealand, which is the Esri User Conference or the Locust Roadshows, days like that. We also have the FOSS4G. So I think this is a space where everybody across all of those sectors can come together and still do that sharing and knowledge transfer and just get to know people better. I think it's always interesting to hear what people are up to, how they got into the profession or where they'd like to go next. Myself, I was 14 and I decided I was going to be a forensic pathologist. I wanted to follow in the tracks of CSI. So for 7 years, finished high school, went to uni, did biomedical science, was about to do a postgrad diploma, that's the one, in forensics. I was really excited, and then I did a summer school paper. 6 weeks later, I'm into GIS, that's it. And the lecturer was like, oh, sure, you can do it. The university said, no, you can't. Had a little wrangle, and I ended up doing my GIS degree, and here I am 21 years later. So never expected to fall into it that way, but I love it. And lots of people are geologists, or they've done environmental planning, they've done other things. It's really cool. I hope that we can all establish that space where people share where they've come from and where they're going to, and just learn from each other. So without further ado, I will hand over to Kirsty. Mickey.
Thank you very much. Awesome. It's great to have so many people here tonight. Really excited by the turnout. So as Sarah mentioned, can you guys hear this okay? I need to hold it really close. As Sarah mentioned, we're collaborating on some of these events. So Women in Spatial and Survey is a sub-part of Survey and Spatial. So we get involved in a lot of these events as well. Women in Spatial and Survey has been around for quite a long time. So what I wanted to do here at the beginning is just introduce a little bit about what we do and what our involvement is in all of this. So I'll give you a little bit of an introduction, go through some of the recent updates. We've got a mentorship program. I don't know if anyone here has heard about that, but that's been going for the last few months, which has been great. And then I'll talk through some upcoming events. Hopefully we can collaborate with the spatial stream on those. So we've been around, we were reformed in 2011 to be part of Survey and Spatial, but we've been around a lot longer. We're all about helping women in spatial and survey careers, but over the last few years, we've widened that to helping support diversity and inclusion more broadly into survey and spatial careers. So we're keen to get anyone involved who wants to support that objective. And being involved in the group, you don't have to be a woman or a minority community, you just have to support the cause. the number one question I get whenever we have events. I'm a man, can I come along? Yes, definitely. So we're all about providing a safe space to build up networking skills, meet new people, give people opportunities to speak so they can gain more confidence. Yeah, lots of different speakers, so it's a great way for people to get to know each other. And as of 2022, we rebranded to go from Women in Spatial to Women in Spatial and Survey. So this is our committee meeting 2 days ago. It's great to have some people in high-vis with us. So they were showing dedication to the cause by joining from in the field. So that's Melindy, who joined us this year. She's at the University of Otago, one of the survey students down there. Yeah. And then that was also Devon, who is now part of the Young Spatial stream. She's also on the council now running that. So she's going to have a lot on her plate. So if you want to hear about what we're up to, we have a mailing list. Just Google Women in Spatial and Survey and you'll find the sign up form there. And we also have a LinkedIn group that's growing every day. So hopefully we'll get up to 800 soon. We're getting close. So a few updates on us. We have now got an Instagram feed and it is now being posted to regularly. We've got someone who's dedicated to it. So you can use this QR code or just look up s+snz. We've got a really cool Instagrammer, is that the word to use? Who loves making these videos. They wanted to make a TikTok, but we thought that might be too much, so maybe later. But this looks really cool, one of the videos we had on there. So we're trying to post all of this stuff and keep some updates. Maybe we'll help the spatial stream create one of those as well. So I also mentioned that we had a mentorship program. So we started that at the end of May, and we've been doing like monthly letters about that. It's a newsletter that goes out each month, giving people a discussion topic, but they set all of their goals for the stream at the very beginning. So we've been having these discussion themes all around networking and interviewing. These have been the last few. So got all these cool little posts for our Instagram account. It's been great to see how active people have been. And through it, we've been getting lots of content of people out doing their jobs every day that we can use to try and encourage younger people to get into survey and spatial professions. And this is just what one of the newsletters looks like. So if you do sign up to the mailing list, we send out those once a month as well for non-mentorship stuff, just going through all the upcoming events. Yeah, and these are some of the social posts we've been getting through it. So we had a day in the life from the surveyors, which looked really cool. Definitely all the construction site and out in the field options. And then we did also have a cadastral post, and we've got our spatial input with the Haraki Golf maps there, which is awesome. So what's up next for us? We have a lunch at the Survey and Spatial Conference. Sarah's actually going to be speaking at that. So if you want to find out more about her career journey, please come along to that. And then we've also got a breakfast at the NZEUG event. So another place to find us. And then, of course, there will be something for GIS Day as well. So I'm sure there'll be more collaboration yet to come. So if you want to get involved as a speaker, a sponsor, or a host of any of the events, feel free just to message us at spatialwoman@gmail.com. Thank you.
Thanks, Kirsty. It's a great update. And so now we're going to hear from Bruce. It's something very exciting.
Do I really need this?
You could be now, isn't
Yeah. Kia ora, everybody. My name's Bruce Robinson, and I've worked at Global Survey for about 20 odd years. And one thing I learned a long time ago is that when people used to ask me, well, you know, what do you do? I used to start to tell them. I get quite excited. You'll see I get quite animated, and I just watch their eyes glaze over. So what I suppose I learned or decided is that how do you describe yourself? Well, it can only be what you put on your departure or arrival card, right? So I'm a land surveyor, right? So that's what I do, and that's what I tell people. Tonight I'm not going to talk about land surveying at all. I'm going to talk about one of my many roles that I have, and I am the, well, I'll read this now, GNSS Reference Station Manager for SmartFix in New Zealand. Right, and that's one of the roles I've got, and this is really quite important to what I want to talk about. There's some other facts on the slide that you may want to know. My email address is at the bottom if you've got any questions. The date of birth, 2nd of February, just remember that, right? And that's less than the year 2000, so I was born last century. Right, And the other thing is I am a Kiwi. I often get accused of being an Australian, but there's no hope in that. So on the 11th of May, I got extremely excited. So what happened on the 11th of May? Right? Do we all see this stuff, right? So just some, first of all, interesting things. These four photos were all taken approximately the same sort of time. First one's by myself down at Browns Bay. Next one by a colleague out of Aurora. Next one out of a mate out of Christchurch. Last one for my darling daughter down in Queenstown. And so it's quite interesting because we all saw different colours, right? We all saw different colours. So what does that tell me? It tells me two things. First of all, the Earth is not flat, right? So that's a good start because that's what we're into, right? We're not in the flat Earth. And the second thing it tells me is that there's a lot of action happening in the southern part of the country. Now, this is just a visual of what we saw, but this was going on all day, right? It's just at night time when there's no sun on the Earth that we actually get to visually see this stuff, right? So this was happening all day, and it was happening from basically about 60 or 100 Ks to 200 Ks. And I want to talk a little bit more about that as I go on. So from that, we get this really exciting map. Have any of you come across a tech map before? Okay, no. Total electron count. Okay, this is what the electrons are doing in the atmosphere. This was taken at 4 o'clock in the afternoon, and this is really quite peculiar. So first of all, May. So this happened in May, right? So May is winter, essentially. We're going into winter. So if you ignore this bottom part, this is what we would expect to see. See, there's some action in the just north. I hope you can all see this is a map of the world, right? Globe. It's flat. Okay, but it's not. Okay, so action happening in the northern hemisphere a little bit. This is solar action, right? And you'd expect to be northern side of the hemisphere because we're into winter. And then, at the northern part, it's pretty low, nothing much happening. Down the southern hemisphere, we should see that very much like this. But that afternoon, it was going crazy. Okay, so I said this made me really excited. Question, why did it make me really excited? 11th of May, run a reference station network. Why did it make me really excited? No answers. So why did it make me excited? Interference, for what? For what? Because I run surveying, GPS, right? Okay, so what I'm going to do is give you guys about a 60% out of 100. The reason why it made me really excited is it happened on a Saturday, right? Because if it had happened during the week, it would have been a bloody disaster for me, right? So why was it really exciting? It happened on Saturday is the correct answer. But what actually happened was this here caused some problems for GNSS, and it's important to understand this. So what actually happens is that the signals travels through the ionosphere, then the troposphere. So the ionosphere is the top part of the atmosphere. And what happens is when we have, I'm going to go back a slide. When we have this sort of action, what it does is the rays of the signals that are coming in from the satellites, they get modified and they get scattered. So that means we get less data down to Earth and therefore we have problems. Okay, so I'll show you what I mean. So let's go to the next slide. So this is what one of my dashboards would look like for SmartFix. And so what this is showing me, it's telling me the stations, and these are the satellites I'm tracking. Green is good. Yellow means that we have problems with those signals coming into our software and we can't really process with those signals. And you can see there's a few little yellow specks. The height of them is where they're sitting in elevation in the sky. And you can see low elevation, low elevation. Yellow is typically low elevation. Red means we think the satellite is there, but we're not getting any data at all from it. Okay, so there's a couple here. This can be bad almanac data. It can be there's just something on the horizons that's not allowing us to get it. May not be up high. So that's what a normal day would look like. 11th of May, that's what it looked like, right? So it was all over the place. You can start to see these are the satellites. You can see some of these ones here, yellow, lots of yellows, lots of yellows. So in other words, we know we're getting data from them, but we can't actually use them in any positioning services at all, right? Because it's not good enough for us to decrypt and use to send back out to a user. Few reds, not too many reds, but the yellows they're still an issue for us. There's some of these reds which are really high is really problematic. Okay, and it's interesting if you look vertically. rather than horizontally, you'll start to see a bit of a pattern. Yellow, yellow, low, yellow, red, all over the place. Okay, yellow's out here. And so what that tends, if I looked at those satellites, they're probably, I would predict, towards the southern part of New Zealand. Right, because that's where we know all the action was happening from. So what did that mean for users? Okay, for users, this is what it meant. If you were working in the afternoon, and Saturday, I've got other things to do, right? Okay, but in the afternoon, I thought I'd get on and start to have a look at some of the stuff. In the afternoon, only 2 satellites available, usable satellites available down the deep south. I didn't measure anywhere with 3, but it's got to have it somewhere between 2 and 4. So I've got a little triangle in there myself. That's me. I don't know. Yeah, so that's my triangle of 3. Okay, 4. Actually, how many satellites do you need to get a position? Try again. 4. Okay, we need to solve for 4 variable, minimum 4, unusable. Actually, really, it's actually unusable. We had people who were trying to dredge in the Otago Harbour, couldn't do it. Right, couldn't do it. Okay, and then as we came up 5, 6, and the North Island was pretty much fine. But it's interesting to see that actually this sort of stuff happens and it's a problem. Last slide. So why does it happen? We're in something known as the solar cycle, right? Which the solar cycle repeats every 11 years. It's pretty predictable. Solar cycle is a subset of the Hale cycle. I'll talk about the Hale cycle in a second. So we are coming towards a peak of that solar cycle. So it's predicted, right? It's when these mass electrons get released from the sun. So some days nothing happens, other days lots happens. So we're coming towards the peak of a solar cycle and we're coming towards summer. Right, so if you go back to that slide where I said we're in winter and we have this action, so it's going to be compounded for us in summer. If there's a mass electron release, we could have problems where we actually lose GNSS. Right, I can't help you. Don't email me. That's why I didn't put my phone number up. Right, okay. So that's quite cool. It's quite interesting to know. So that's why we're heading for it. But what I think is quite cool, like how do they know that it's going to repeat every 11 years? Okay, it's because Mr. Hale worked that out, right? And the Hale cycle happens every 22 years. So we get repeats every 11 years as it happens. So what Mr. Hale discovered is when this mass ejection happens is when the sun swaps its polar axis. So every 11 years, essentially, what happens is the north of the sun comes down. It's about to transition to a southern, and this is when all these electrons get released. Then when it gets to the south, when it swaps over, then we come back into this calm period. And then the sun goes through that process again and reflips, and every time it flips its polar axis, we get this mass ejection of particles that can affect our lives. And we all understand that GNSS not only runs our positioning lives, but it runs all our lives, right? All our banking is run via timing. You send money, how do they know when you send it so you can't take it out? All done by GNSS, right? So this here is going to be interesting, right? Thank you. That's the end of my presentation.
Thanks, Bruce. I really love that. And I thought after I saw it the first time that it would be a perfect time to commit a crime, right?
We'll go withdraw your money from the bank, right?
Yeah.
So I would like to pass to our next speaker. Murdad, would you like to go? Yep. Great. Yeah. Here we go.
Okay. Yeah, because it is Survey Spatial New Zealand. I thought many of the people in this group should be surveyors, but it was a mistake. Anyway, I'm a surveyor. I've seen some problems can be solved using GIS in surveying, and can be a powerful tool for the surveyors. can help provide surveys. As I mentioned, it's a powerful tool for data management, visualization, and analysis, and enhancing the precision and efficiency of their work, and also by integrating data types such as aerial imagery, property boundaries, GIS facilities, comprehensive site assessment, and accurate map creation. Sometimes it happens in surveying that we bring many sources of the data, many data from different sources, and with different coordination system, with different sources, and we need to put them together. One of the good tools for that is GIS. We can have them in one place. We can save it in one place and manage it easier. And it can also automate routine calculation. Sometimes we have some calculation and we need to make it automated. GIS is a good tool for that. And also I provided an example of GIS, how GIS can help us. Why it hasn't changed? Okay, so working. It's all right.
Can't help you, PowerPoint. I'm sorry. Yeah.
Yeah. Yeah. GIS can be used for air pollution modeling. We can apply GIS to model air quality variation across Auckland, which is this. It is the integration of many data, including traffic, population density, and real-time measurement to find out what is the amount of air pollution in Auckland. As you can see in here, there are lots of air pollution. And also we can have what if scenarios and say, for example, how many lives can be saved if we decrease air pollution in some areas. This is the average of the NO2 for northern part, east, west, and center. And that's it. Yep.
Thanks, Murad. It can definitely solve almost all your problems on GIS, except for PowerPoints, as I said, Sam. So now I would like to pass over to our other Sam Blackburn from Civics, and also he's going to talk to us about All-Site AI, which is fascinating because his business is actually put into production. I spend a lot of time using Gemini, and I ended up in fights with it, saying, why don't you know you're not called Bard anymore, you're called Gemini, and it tries to argue with me. That's a very, very painful way to use it. So this is going to be a great presentation. Over to you.
I didn't give you pizza toppings because you'll get glue in it. Yeah. Might queued up next or thank you. Yeah, so my name's Sam Blackburn. I'm actually a chartered professional engineer who spends a lot of time in GIS. I sort of in my early career as an engineer, I kind of only learned GIS. I never really got into CAD or 12D. And so 8 years ago, I started a land development consultancy, and I was quite into software as well. So we started actually just building our own technology on top of ArcGIS to do land development design. So all of the drawings, production, everything. It was definitely the hard way to go about things. But it's developed a lot over the years and has become, quite a powerful tool for how we work. 5 years ago, we sort of came up with an algorithm for designing underground networks that automatically have smartly avoided clashes and kind of optimized network design. And that gave us the sort of confidence to actually go and do this commercially. So 2 years ago, I started All+Site AI, and poached a couple of top AI engineers out of Fish and Paykel Healthcare. And yeah, we've sort of got our first products in the market now, which is sort of a true AI automation for sort of land development design. Why would you do engineering design in GIS? Well, it's all about, if you're trying to fully automate a system, you need to have all the information in there and have a lot of spatial knowledge about how things interact with other things. And that's exactly what GIS is really powerful at. So there's the concept of geodesign, which is using GIS to sort of lay out cities, overlay environmental and other constraints to come up with sort of better layouts for cities. And our technology is really kind of taking that down to the site scale. It's not that much about the environment, but it's all about sort of the land development form, how it needs to look, what rules it needs to comply with, and what's the sort of optimal way to design a site, given all the constraints that an engineer would normally think about when they design these things. So this is the dream. It's not the reality yet. So we're trying to work across sort of building a system where you could just give it the outline of a site and it would go and come up with a layout, design it in 3D, and design all the infrastructure to service it. We may never get that level of autonomy in terms of the systems we're building, but we've made great progress in the 3D design space. So given a bulk and location plan from an architect or a layout from an urban planner, we can turn those into real 3D models and schedule all the roading and buildings and earthworks associated with what needs to happen. We are currently training a machine learning model on development layouts. So we've taken the last sort of 20 years of title information from all the countries around the world and are just looking at what developments went in and what the shape was and what the context around it was, and using AI to sort of train something that could then take a new development and come up with a layout that's actually pretty good. We don't anticipate that being ready anytime soon because it's a lot of work. And in the service AI space, that's all about generating sort of pipe designs, manhole layouts. And as I said, we've already got an automation there in terms of the vertical level of those systems. And by the end of the year, we'll have something that works in the horizontal space, which I'll talk a little bit more about today. So to do this, we put all the detail in everything an engineer thinks about. So I don't expect you to read this slide. It's got far too much information on it, but that's sort of just highlighting all the detail that you need to put into these systems. So when you think about geodesign and that layering of information, that's really what we're doing, is all those engineering constraints getting put into the model so that it can really understand spatially what the design needs to do, and then enact sort of coming up with a design for the site. And I've got 4 projects that I'll go you through today, which sort of illustrate how the system works and give you a better idea on how GIS has been used to achieve these sort of design goals. So we're actively trying to sell the software in America. So we've got some sort of American examples to show you today. So this is a 250 lot site in Austin, Texas. The design was actually done in Civil 3D. This was done as a case study for us to test against what the engineers in America had come up with for the site. So it takes us about an hour to load this line work in. It's what GIS are probably quite used to, is you've got a DWG and you've got to, like, that's a building, those are boundaries, that road's a local road. So typing up the roads so that they can see what design constraints they need to use, setting grading parameters on the lots so that it's smooth and people want to live there. And these are retaining walls. There was a few retaining walls on the site and existing pond structures that we needed to tie into. So yeah, it took us about an hour to draw that up. And then the system goes up with all the constraints into the cloud and runs on GPU clusters. This is another reason why GIS is really helpful for this, because GPUs think in big arrays of numbers, and that's exactly what rasters are. And so we rasterize a lot of the data that goes in, and the actual engine that thinks about the design is a raster-based engine that's coming up with sort of the layouts for these sites. And so what you get back is a fully vectorized 3D model. So we've got sort of the raster and the vector world talking to each other in the model so that it can come up with a design that really works. And it just keeps iterating in the cloud to sort of perfectly balance the earthworks. So it's very useful in that it'll do the iteration for you. So it took about half an hour to solve this site. So an hour draw time, half an hour run, and then you've got back a full 3D design of a 250 lot development. So these normally sort of take maybe a month of man hour for someone to design manually in 12D or Civil 3D. So it's quite a step change in how efficiently these things can be done. In this case, it's sized a couple of stream crossings here that are culverted. It's also sized retaining on the hill. It's decided that most of the grade change should be on the boundary there, but if you've wanting to keep your walls lower because of grade constraints, you can just set restrictions on it. So as you overlay more information as the AI, it'll then respond with a design that meets those objectives. Yeah, it's just another shot of it showing that. So it's thought about flooding as it goes. It's thought about connectivity of stormwater and wastewater networks. It's thought about all the roading vertical geometry parameters. Funnily enough, Texas, when you convert their roading standards from feet to meters, has exactly the same rules as Austroads, which was quite nice for us. We didn't have to rewrite any rules. And as it runs, it produces cut fill plans, cut fill drawings, quantity estimates of what it's going to take. And it'll just, as I said, it's balance the site perfectly there. So it's just constantly iterating on the design to achieve a balanced outcome. It also scales really well. So another reason to use GIS is that it's built to handle city scale data. So on this project, this is near 2,000 houses, and we can sort of, this took 4 hours for us to draw up, just a bit more data to bring in from DWG, and the company that we're working with gave us a folder with over 100 DWGs in it. So we had a bit of searching to do. But we're loading it up and getting it running. And then this one took 2 hours to solve in the cloud. So the system's got a lot more to think about for bigger sites, but it can still get through them. And then, yeah, sort of in a few days, you've got a full 3D design back and cut fill. It'll also balance the cut fill for each year of the development. So it's quite powerful in how it thinks about things. You can also tell it, I've got some extra dirt from another site that I want to lose in the model. And then it'll go in and redesign the surfaces to account for losing that sort of material. This is a local example back into Warkworth. So this is sort of illustrating the ability to run different comparisons in there. This is all stored in file geodatabases. So we just have scenario management where we'll swap out the geodatabases for different scenarios and can run different controls on the site. So this example on the left was pole houses. So this is a 15% grade site in Warkworth. So pole houses means a lot less retaining, a lot cheaper, but it was an end product that was going to be harder for the developer to sell. And then the alternative on the right there is slab on grade sections, but they require a ton of retaining. So this site's actually still on the market if anyone wants to buy it, but it is very steep. And then moving on to sort of the servicing space, as I said, our servicing model isn't finished yet, but it is, heavily utilizing GIS again to do this. So we're building up sort of very detailed rasterized models of what's on the surface. You don't want your manholes to be placed on a curb. So it's got to tell the AI sort of where things should be placed. And then in terms of how it thinks, we've actually built a voxel engine. So probably a lot of the geospatial people here know what voxels are, but voxel is basically rasters in 3D. So it's a layered raster where it looks like Minecraft. Everyone understands Minecraft. So that's how the sort of infrastructure AI works, is it's searching through those Minecraft blocks to find the best path for the infrastructure under the ground. And it can take into account things like clashes and stuff, because those blocks will be, glowing red lava or something. So the pipes don't want to go through them. So, yeah. So we're building that at the moment and hoping to have sort of a prototype running at the end of the year, which will allow us to lay out sort of pipe manhole networks. It's a very logical system. It's not going to pick the appropriate place for the wetland in your development form. That'll still be done by real engineers with real knowledge, but it's all the sort of more logical work. Like once you have a wetland, you need a bunch of pipes to connect to the building to bring the water in. You need catch pits to be placed. That's what our AI will be able to generate. And then the connection of the wetland into the downstream networks as well. So yeah, a bit more development work to go on that, but it's getting there. And this is what we have currently. So given a 2D layout, so our engineers drew this in 2D, and then the AI sort of generates the 3D. So it's running sort of a smart sort of inverting analysis, trying to comply with water care clearance requirements, sizing the grades of the pipes, making sure that those work, trying to minimize the depth of the pipes, but then also not make them too shallow so they don't get damaged. So it's just balancing a whole bunch of different stuff and then trying to come up with that sort of ideal network design for how deep the infrastructure is. And yeah, we also built trench modeling software as well. So it's a one-click to get full trench models of what the excavation is going to take. This, I think, would have been very hard to do in a vector world, but in GIS with all its buffering tools and spatial analysis tools and raster-based stuff, this didn't actually take us that long to put together. And it's a really good way of understanding sort of how construction is going to go. It provides really accurate estimates of the materials you're going to need to take out of the ground for your trenches, and helps you also understand sort of buildability constraints. So this was actually a neighbour approval. So you could go to the neighbour and say, the excavation is going to be this big on your driveway. We'll be reinstating all of this. So it's a good information source, and it smartly switches. So if this was actually a drilled line, so it hasn't drawn a trench there, and that trench used trench shields. So it's got vertical sides. So you can look at sort of, as you're doing your construction, switching out how something's going to be built and seeing what the effect is on the sort of excavation required to achieve your goals. Thanks. Yeah, that's quicker than I normally do it, but yeah.
Thanks so much, Sam. I just really want to geek out and play with it actually after seeing that. And I love how you keep bringing it back to how GIS was relevant for everything that you've done, and you've built a dream, and it's amazing. You can go through all those iterations so quickly. Is there anything it can't do? I'm thinking of emergency management. I'm also a committee member on GMA, and I'm just thinking, imagine all of that. Oh, it's so good. It's so good. Does anyone have any questions for Sam or any of our speakers they wanted to raise? Sea of silence. Okay, I'm going to close it there. So thank you so much for coming along tonight, everybody. It's been really good to meet lots of different faces. And also, we plan to do these events probably every 3 months to try and get people together. So different places, different themes, different speakers. And we also really want to hear back from you, because this is a community for all of us. We've the committee that's come together to push this ahead, but it's to benefit everybody. So if you've got ideas, or you've got something that you'd like to share, a cool process or a project that you've worked on, please get in touch. It'd be great to hear from you. And otherwise, just watch out for LinkedIn feeds and emails from Survey and Spatial New Zealand, and we'll keep you posted. So thank you again. Please feel free to stay on and enjoy the rest of the drinks and any nibbles that are left. And I will close it. I'll say thank you all online.